A body at rest is given an initial uniform acceleration of 6 meters per second squared. So what I want to do here in solving this question is to, as I read the question, as I read the sentence, I state the variable, the parameters mentioned in the question. Because you can see it's pretty long and it's not even giving me space to solve it. So let's take it line by line. A body at rest, meaning that its initial velocity is zero, because the motion of the body begins from rest, and is given an initial uniform acceleration, that is constant acceleration for a while, for about 20 seconds. The constant acceleration is 6 meters per second squared. And the time of 20 seconds, meaning that the body maintained this constant acceleration for 20 seconds, which means it's possible to use the equation of motion V equals u plus at to calculate the speed attained by the body after moving with a constant acceleration of 6 meters per second for 20 seconds. Starting from rest, u is 0 plus 6 times 20. So that will give me a velocity of 120 meters per second. That is the maximum velocity attained by maintaining a constant acceleration of 6 for 20 seconds. And how do I show that graphically? Because if you come down here, the question says draw a velocity time graph of the motion of the body using the information given about the motion of the body. Okay, let me just, before I move to the next line of the question, I want to quickly do a sketch or draw or start drawing the velocity time graph of this body. Okay, this is time and this is velocity in meters per second. Okay, so if the body, since the body starts from rest and maintains a constant acceleration on a velocity time graph, that should result in a straight line graph that starts from the origin having a positive inclination to the time axis in seconds. So this point here corresponds to my 20 seconds, and this velocity attained here is my 120 meters per second. A body at rest is given an initial uniform acceleration of 6 meters per second square for 20 seconds. So that is the graph that represents that information about the motion of the body for the first 20 seconds. Then after which, 20 seconds after, maybe the driver discovers that it's running too fast, because when you maintain a constant acceleration, your speed keeps increasing. For instance, the next second, that is the 21st second, the speed will have increased to 126. That is, it increases by 6 meters per second every second. By the 21st second, the speed will have been 126. In this case, the driver may be overspeeding, which can result in accident and that may even cause his death. So he decides to reduce his acceleration. To reduce the acceleration does not mean you are reducing speed. To reduce the acceleration means you are reducing the rate at which your speed is increasing. Here, the speed was increasing by 6 meters per second every second. So when it reduced that to 5, it means that the speed is now increasing at a lower rate of 5 meters per second every second. Though it's not still as low as we think, because there's not much difference between the 5 and 6. Okay, let's go with the question. It says the acceleration is reduced to 5 for the next 15 seconds. That is, in this case, because I'm still going to represent this information, the second statement, acceleration of this for 15 seconds on the same graph. I'm going to continue because it's a continuous thing. The man did not stop the vehicle, or the body did not stop for some time and then the other statement applies. No, it's a continuous thing. So which means before the acceleration of the body was reduced, the initial velocity should still be 120 because the body was not at rest when this acceleration was applied. It was already in motion. It was already running at a speed of 120 before this acceleration was reduced to 5, meaning that we'll take this as initial velocity for this second stage of the journey. And then the acceleration is 5 meter per second squared. The time is 15 seconds. Now, what is the speed attained this time around? After 15 plus 20, that is after 35 seconds. What is the speed attained? The speed now is that we use this same equation because it maintains this constant velocity for 15 seconds. So the speed attained is, this is 120 plus 5 times 15. So that will give me 120, 5 times 15 is 75. 75 plus 120 gives me 195. 195 meters per second. 195. So I'll come here. This is 120. And let's say this time I had 15 here. That will give me 35 at this point. You add 15 to 20. So you plot that against 195. Let me call this point 195. And that 195 is the maximum speed attained by the body. Okay? So give me something like this. You can see the graph is not in the same line as the first one because this is a graph of reduced slope. The slope represents acceleration has decreased because the slope of this graph is greater than the slope of this graph. How do you know when you're given two different graphs like this? When the graph bends more towards the vertical axis, that's in the direction of increasing slope and increasing acceleration. But when the graph bends towards the time axis, that's a graph of decreasing slope and therefore decreasing acceleration. So this is it for 35 seconds. And we're told that the body maintains its speed attained for the next 50 seconds. It's attained a maximum speed of 195 after 35 seconds. And it maintains it for the next 50 seconds, meaning that it's no longer accelerating. So we're going to draw a straight line parallel to the time axis. That is for the next 50 plus 35. That gives me 85 seconds. And then after which is brought to rest in 30 seconds. Brought to rest uniformly in 30 seconds. That is, I have to close this graph by including the part of the graph that represents uniform deceleration brought to rest here. When it's brought to rest here, the final speed is 0. So this is the shape of the velocity time graph of the body for uh, 115 seconds. That is, if you add 30 to 85, it gives you 115 seconds. 115 seconds is the total time taken by the body in the motion. So we start from rest at point O, moves to the constant acceleration of 6. It attained a maximum velocity of 120 at first, and then its acceleration is reduced to 5. And then why that happened, the body was still in motion. So before the acceleration is reduced, of course, it has an initial speed. That's a speed of 120. That becomes the initial speed. Then the acceleration, then time is 15 seconds. Then what's the speed attained after 35 seconds for the next 15 seconds? The next 15 seconds, I have to use this as 120 plus 5 times 15. That gives me 195. Okay, how do we, that's the maximum speed because the first question says we should, from our graph, determine the maximum speed. So number one, the maximum speed attained by the body is 195 meters per second. Okay, then the average retardation. Average retardation, we come here, we use the formula V minus U divided by time taken for the retardation. So my V is when the body is at rest, when it's eventually brought to rest. The final velocity is 0. And before the brakes are applied, the body was already cruising at a top speed of 195. This point corresponds to 195 meters per second. It was already cruising at a top speed of 195 meters. So I put it as 195 over the time taken for deceleration in between. Of course, you are told that it's brought to rest in 30 seconds. So that's my deceleration. So my deceleration is going to be, my acceleration rather is negative, and that gives me my deceleration of 6.5 meters per second squared. Of course, this is my deceleration. I did not include the negative sign. Negative acceleration is deceleration. Okay, the next question says you should calculate total distance covered. Oh, so it was some time. Oh. This is the area under this. Let's call this S1. That is the distance covered in the course of accelerating at the rate of 6 meter per second square. That's area of a triangle. S2, area of a trapezium. This is a trapezium. S3, area of a rectangle. And S4, area of a triangle. I'm sure you'll be able to use the different formula for finding different areas to calculate the total distance covered. So the total distance covered is S1 plus S2 plus S3 plus S4. I won't have all the time to find the respective areas under the different shapes, but S1 is a triangle that is half base. The base is 20, that is the time. The height is 120 times 120, so S1 is 1200 meters. Then S2 quickly is a trapezium which is half the sum of parallel sides. These two sides are both parallel, and that gives you 120 plus 195 times the height, which is 15. This is my height, 15. So that will give me, you can work that out for me. Then S3 is the area of a rectangle, which is length times breadth. This is 195 times, this is my breadth, that is 50. And then my S4, you can work that out for me also, is area of a rectangle, which is half base times, height. My base is 30, my height is 195. So that's what we how we do it to arrive at S1, S2, S3, S4. So when I sum all together, I have my total distance. So that finally my average speed, of course, you know that we define average speed as total distance covered over total time taken. So my S, which is the sum of S1 plus S2 plus S3 plus S4, gives the total distance over the total time taken, which is 115 seconds. By the time you add up all these times that indicated in the question, that gives you the average speed in meter per second. We always see that the average speed is not the same as any of these speed, especially it's not the same as the maximum speed attained. Yeah, so you just use your calculator to get all these values, input them here, add them together, and then determine your average speed, total distance over total time taken.